Hello everyone, in this video we are going to see some basic concepts of DC machine and how you can solve questions by just knowing the machine and using two formula. Yes, we are going to study only two formula today. So let's start this. So this is a basic DC machines and it is separately excited. Okay, so why it is known as separately excited? Because its field winding is separated from the armature winding. There is no connection between these two and therefore we consider field flux or basically flux as constant in this case. Now let's come to next machine which is shunt DC machine. Here the field winding is connected to the main winding like this. So this is a shunt winding and this is a armature winding. Except for few cases, here also the flux is constant. Now let's come to the last machine which is series DC machine. Here this is the series winding and this is the armature winding. You can see clearly that here the flux is not constant. It is varying due to variation in the armature current. And there are other types of DC machines also, but they are basically combination of any of these two or three. Okay, so here we have two separately excited DC machine. And now we are going to see which one is generator and which one is motor. Let armature current is flowing in this direction here, and in this case it is flowing in this direction. So talking about our first case, here the supply voltage is supplying current to this machine. So this cannot be generator, this is motor. And in case second, machine is supplying current. So this will be generator. So there is no difference except for the direction of armature current. So in case of DC motor, we will write E induced EMF is equal to V minus IA armature current into armature resistance RA. And in this case, we'll write E is equal to V plus IA RA. So this was very simple. You are just knowing your machine. Now, as I said earlier that we are going to learn only two formula. So, these are the two formula which are going to solve maximum questions of DC machine. So, first one, E is directly proportional to pi omega and second is torque is directly proportional to phi Ia. This is armature current, this is field flux, this is torque. This is speed which is in rad per second, but since it is proportional, so you can write as pi n. Here n is in RPM, revolution per minute. And E is induced EMF and pi is again field flux. So this is a very simple relation. You can learn this. And now we are going to solve question using these two. Okay, so this question is from GATE 92. Now neglecting all the losses, the developed torque of a DC separately excited motor operating under constant terminal voltage is related to its power, its output power P as, and there are four options. So first C, this is DC separately excited, which means pi is constant. And then it is motor. So E is equal to V minus IARA. Constant terminal voltage means V is constant and all the losses are neglected. So we can say that this IARA will be neglected because RA contributes for its loss. So clearly you can see that E is constant. Now for DC motor, output power is E into IA and clearly E is constant, so P is directly proportional to IA. This is our equation number 1. And now we all know that T is directly proportional to phi IA And since phi is constant because it is separately excited motor, T is directly proportional to Ia. So from 1 and 2, you can say that T is directly proportional to P. Option B is correct. Okay, so this question is from GATE 2012. Here, a 220 volt 15 kilowatt 1000 rpm shunt motor with armature resistance of 0.25 ohm. Armature resistance is 0.25 ohm. Has a rated line current of 68 ampere. So it has line current. Remember, it's line current. And since it is motor, so current will go like this only. And rated field current of 2.2 amperes. So 2.2 ampere is this. The change in the field flux required to obtain the speed of 1600 rpm while drawing a line current of 52.8 ampere and field current of 1.8 ampere. So these are the two conditions, and here the speed is 1000 rpm. You have to tell the value of the change in the field flux in percentage and also whether it is increasing or decreasing. So now consider this as first case and this as second case. So here the armature current will be 68 minus 2.2, which would be 65.8 ampere. Therefore, E induced EMF will be 220, which is supply voltage 220, it was given, minus armature current 65.8 into armature resistance, which is 0.25. So here E will be 203.55 volt. And in this case, it is 52.8 ampere line current. And field current is 1.8 ampere, so armature current will be 51. And similarly, induced EMF will be V, which is 220 volt, minus IA 51 into 0.25. So E is equal to 207.25 volts. So in first case, E is 203.55 and in second case, E is 207.25 volts. And now we know that formula E is directly proportional to phi N. So E2 upon E1 is equal to pi 2 upon pi 1 into N2 upon N1. So by placing all the values, 207.25 upon 203.55 is equal to pi 2 upon pi 1 into 1600 upon 1000. So here pi 2 upon pi 1 will be 0.6363. So you can see that there is a decrease in the flux, but we want the value, so we want pi 2 minus pi 1 upon pi 1 into 100. So this will be pi 2 upon pi 1 minus 1 into 100, and therefore we'll place all the value. So this is equal to minus 36.36%. Minus indicates the decrease in the flux. So option D is correct. So I guess now you will understand why I was saying that those two formulas are very important and it can be used to solve any or maximum problems of DC machines. Thank you.